All right, we are live. Welcome to our live chat. Of course, it is July 13th, 2022. It's 8 p.m. And thank you, as always, for joining. Just check. Video's good. Everything's good. Okay. So it looks like everything's good. So, how's everyone doing? We're going to talk about a couple of things this evening. We're actually going to go back and look at yesterday's thunderstorms to kind of learn about how they developed, why they weakened, and how the whole evolution of the storm process took shape. Also, we're going to take a look at some of the new model data we have out for this afternoon. Some interesting data in terms of the potential for more rainfall, why I'm a little bit skeptical, and why at the same time it could be something, well, maybe a little bit of hope. Maybe a little bit. But before we get to that, we need to discuss what happened yesterday. So I pulled up some archive data, and let me go right here. Now, granted, this isn't the flashiest graphics, but it gets the point across, okay? And this is from ncei.noaa.gov. You can see up here under radar. You can also Google radar archive, and this is the government source. So there you have it. I kind of pulled this up in a pinch. And here we have yesterday afternoon. We had three lines. One here, and one here, which aligned perfectly with the HRR data and the NAM data. Now, the HRR and NAM data both had all three of these lines marching across. We had a bit of a divide here, which was already showing up in the observations. But this thunderstorm cluster here was going to intensify while this dropped south and marched through the New York City metro, northeastern New Jersey, New York City, Long Island, with very heavy rainfall, possibly a severe thunderstorm. Okay, that's what was the forecast on both of the mesoscale models. Reality was, by the time the storm hit northeastern New Jersey, it collapsed. And, well, there you have it. Everyone's saying, my grass is brown, what's going on? I heard about rain, no rain, I had a drop. So what's going on here? Well, let's look at the evolution of these thunderstorms. And it goes in 5-minute intervals, and you can see the thunderstorms forming. Now, let's go back 5 minutes. Right here, you see this point right here? We were starting to get to the point where we were starting to see an intensification of the thunderstorms. At this point, and I shared this on Twitter, if you guys are following on Twitter, we had significant instability here with a lifted index around -7, which is pretty impressive. Plenty of moisture, so you had like a reciprocal water values around 1.9 and plenty of vertical wind shear. So you had the three ingredients needed to create an intensifying line of thunderstorms. And in fact, it did intensify a bit, where you started to see more of a consolidation of the line here with rising echoes. And you had a tornado development here with this cell, and you had intensification with these cells. And of course, you had this part of the line intensifying as well. So that aspect was working out. Then, 5 minutes later, it all started to come apart. Now, there are a couple of reasons why this thunderstorm cluster, as it was marching east, started to weaken. The first thing you could assume is that, well, this line was intensifying, so the substance from this line influenced this line, which caused it to weaken. A fair assumption. Another suggestion was that this line here, because it was intensifying, also weakened this. So you had two areas of substance. Certainly a fair observation, and one that would support the idea of weakening. But why a complete collapse? Well, that's where we go to our soil moisture. This is the latest soil moisture analysis from Drought.gov. Okay, so this is again another NOAA site. And you can see right here, very dry conditions. It's actually not too bad in terms of the soil moisture in northeastern New Jersey. The reason why you're seeing browning of your grass is because grass is very sensitive to lack of rainfall. So it's going to notice the impacts first, okay? Your soil moisture is going to take a little bit longer because of the very wet spring that we had. but it's starting to catch up. But this area right here is your killer. Let's see if I can zoom in here on this. You see this right here? This area of dry soil combined with the downsloping impacts from the Appalachian Mountains to the Hudson Highlands to the coastal plain combine to lead to an environment that is adverse for thunderstorms. If you have any limiting factor in with those thunderstorms, a little bit of subsidence, a little bit of surface divergence, anything of that nature, conflicting outflow boundaries, okay, anything mesoscale or microscale that can start to weaken thunderstorms, this dry environment here enhances that weakening. So it's basically like diamond dust on a baseball field. It dries everything up. So it's not necessarily the conditions over northeastern New Jersey. It's the conditions just to your west and in central New Jersey, right over central New Jersey through Trenton and in the northern suburbs of Philadelphia. Notice very, very wet conditions are to the south and west of Philadelphia, where we've been seeing plenty of thunderstorms able to intensify and able to remain sustained. And that sustained nature remains the case even in a very dry area like southern New Jersey. Now, why is this able to still feature strong thunderstorms like what we saw yesterday, where that line just marched right through? Now, notice, even in those dry conditions, it still weakened pretty significantly, but it didn't completely collapse. The reason why? Delaware Bay. You have a low-level moisture source that these thunderstorms are able to feed on. So you have a little bit of support in that respect. So you have to kind of combine factors here, okay? You have the soil moisture factor. You have the direction of the thunderstorms downsloping off the Appalachian Mountains. You have two large lines intensifying to the north and south. The combination of those factors weakens this. Now, the HRR and the NAM model guidance had this line strong, but the strongest part was up here. And this part, the strongest part, was further south, more towards Washington, D.C. It didn't really impact the Delmarva Peninsula. But in reality, the strongest part of this line ended up heading right towards the Delmarva Peninsula. So you have all this rising air here, and so you end up with sinking air here. All this rising air here rather than here, so you end up with sinking air here. So the combination of these things, boom, weakened the thunderstorms. So that's what happened yesterday. Was a severe thunderstorm watch warranted? Absolutely. Because you're talking about factors that were changing by the minute. So if you are trying to put out a watch a couple hours ahead so people can prepare, you don't have the luxury of saying, well, we'll just wait to see exactly how these lines form, and then we'll put out our watch. That's what warnings are for. So the watch was definitely warranted, but this is an excellent example of how not just mesoscale, but microscale factors, which I discussed last week, can really impact a severe thunderstorm forecast. And I wanted to go back and show you this because it illustrates so much how these small factors interact and create this type of evolution where the thunderstorms basically collapse and you end up with almost no rainfall. So now looking at this, is there any hope for us to see a significant rainfall event? What is it going to take? Is it going to take tropical storms? Is it going to take a change in the seasons? Well, let's take a look at that factor. First of all, let's look at what's going on right now. We have our trough off to the west, and we have our thunderstorms popping up here. Now, take a look at the surface fronts here. And notice we have a stationary boundary over the region, another one off to our west. So what in the heck is causing that? Let's take a look at our water vapor. Actually, you know what? First of all, let's take a look at our precipitable water values. Pull that up. Let's zoom out for US. Okay. So we have three boundaries. We have our tropical air mass, our modified polar air mass, and true polar air mass. The tropical air is clearly focused from the Gulf of Mexico through the southeast and then over the southern mid-Atlantic. It's starting to push into Virginia, the Delmarva Peninsula. We are somewhat humid, but it's a mix of maritime air, polar air, and modified tropical air. So it's a combination of those three factors. And then here's our true polar air back here. We take a look at the upper level winds, and this is the current observations again. Here's our Western Atlantic Ridge. Here's our positively tilted trough. This is important. See this feature right here? Remember this feature when we take a look at the model data, right? This feature right here sets up a scenario where cold fronts have a hard time moving to the east. They basically keep on stalling out. So we don't see a lot of change in our air masses. So what you see is what you get. The only thing that is going to change this is the fluctuation and the difference in strength between this trough and this ridge. And that shows up very nicely on our water vapor satellite picture. This is an upper level low, which, by the way, pretty much puts a kibosh on tropical development around the Caribbean and Gulf of Mexico for now. That's probably changed towards the end of the month. We'll talk about that in a bit. But you can see in the upper levels, there's our Western Atlantic Ridge. Our upper level low is under the ridge. And then here's our trough. And then here is our boundary setting up. So now we have a basic idea of the pattern. This is a pattern that supports pop-up thunderstorms, but because you're having all these different interactions, you see all this kind of dry air in the mid-levels here, that interaction inhibits the development of an organized low-pressure system with just a slug of moisture to march up the coast. That's what you need. Whether it's tropical or extratropical really doesn't matter. What you need is a large-scale rain event that can overcome these mesoscale and microscale influences and just produce a steady, moderate rainfall for the whole day. Once you get that, then you break this influence, and then you can get thunderstorms just marching right across the region. So the only way to really get that is to allow the Western Atlantic Ridge to flex just enough to push that tropical air in here to allow for a wave of low pressure to basically march up towards, let's say, the Poconos and Catskills and head up towards central New England. If you get that, then you get the environment set up to support a heavy rainfall event. So let's take a look at some of the model guidance here. This is the surface model guidance here. And there's our Western Atlantic Ridge. There's our troughs and cold fronts. Rinse and repeat. And then you see this widespread rainfall event. Be careful with buying into this, because this, to me, we don't see any organized low pressure system. We just have a lot of boundaries here. This looks like convective feedback to me, because this signature showed up a couple of days ago and it ended up looking like, well, basically scattered nonsense. Basically what we saw today. Basically, this signature that we're seeing 7 days out ends up being this. Understand? Now, the reason why the models produce that is because it takes this type of convective output and just produces a whole lot of QPF spread out, because it can't handle this type of lifting this far out. And so rinse and repeat, rinse and repeat. I don't see any strong lows. Don't see any strong tropical systems either, by the way. And I want to show you the 850 millibar winds. This is the European ensemble guidance. Take a look at the factor. I'm going to march you through this. You try to think about what I am focusing on when I'm looking at these winds. And then I'll tell you. But let's see if you can do a little bit deducing on your own. So here we are, we're marching across. and across. Do you catch the theme? I'll give you a second to think about this. We'll march it through again. What is the theme here? Okay. Okay. I think I gave you enough time. The theme in this weather pattern that we're seeing in the ensemble guidance is that our Western Atlantic Ridge is going to flex, but the strongest mid-level winds remain off the coast. What this would suggest is that the evolution of our pattern is such that we'll remain in a hot, humid weather pattern, a thunderstorm pattern, but no sign of a widespread rainfall event. Now, this could be positive and negative. It's positive in that, okay, you still have frontal boundaries hanging around, because notice in that entire time period, we had winds and northwesterly winds from the northwest over the Great Lakes, westerly winds over the eastern Great Lakes, and southwesterly winds over the northern Atlantic. What does that mean? That means a cold front's not going to be able to move through here. It's going to stall out, which means we still are going to have thunderstorm threats here. Throw that in with precipitable water values through the 10-day period. They are going to have the potential to be pretty impressive. We continue to see this spiking of precipitable water values over 2 inches. So we're in an environment where if you get thunderstorms to spark, they'll be able to produce a lot of rainfall, just not in a widespread area. And then we take a look at our temperatures. We'll take a look at this theme here. I'm marching through this every time. High temperatures. I want you to keep an eye on where these temperatures are spiking. See that? Okay. So what we're seeing here in the surface temperatures, again, you don't want to go verbatim, but you're seeing a focus of your hottest conditions around the I-95 corridor in the Delaware River Valley. A lot of days where we have temperatures in the 90s. We also have pretty strong signal of frequent sea breeze fronts and mesoscale outflow boundaries. So the model guidance is trying to pick up on the potential for these thunderstorms popping up via reaching the convective temperature, and you have the development of mesoscale boundaries. So let's piece this all together now. We have an environment right now. Let me put my mug on here so that way we can really think about this here. Okay. We have a boundary layer right now that is dry, that is inhibiting thunderstorms. But we're moving into a pattern now where we have more tropical air. We have a clear scenario where synoptically we have stationary boundaries around the region. We have a Western Atlantic ridge transporting tropical moisture and keeping our temperatures in the upper 80s to mid 90s for high temperatures, which is going to get us awfully close to our convective temperature. That's where we break our cap. We have signals of mesoscale boundaries like sea breeze fronts, stationary boundaries from the synoptic scale influences, and mid-level winds that are generally weak. The strongest mid-level winds are over the ocean, but they're persistent from the southwest, which means you're not going to be able to have cold fronts to move through. You're going to have a continued thermal gradient at 850 millibars with the hottest air along the coast and cooler environment over the interior. You don't have any tropical systems, but you have plenty of triggers in place. So, if I was in northern New Jersey, what we would need to look for are thunderstorms that move slowly and first erode the drying influence over Newark, Jersey City, basically northeastern New Jersey. So what we would need to have triggered here is a sea breeze front that comes in from Monmouth County, pushes in from JFK, and heads towards Manhattan. If you get that, which is possible based on this pattern, with the amount of moisture in the atmosphere, you will end up with the potential for thunderstorms that are going to train and a heavy rainfall event. Further to the north and west, towards northwestern New Jersey, what you would need is a stationary front to spark off these thunderstorms that will weaken but will put enough of a dent into this dry environment that starts to erode that influence. It would probably take about another 3 weeks before we actually get a significant widespread rainfall event, unless we add tropical considerations, which right now we can't. So that's how I kind of see this playing out here. Based on all the observations we're seeing here, a lot of pop-up thunderstorms, a lot of humid afternoons. I mean, it is the middle of summer, so you would expect that. But I don't see any signature of a major breaking event. Now, I did say I was going to talk about the tropics, so let me pull this up real fast. Obviously, the tropical Atlantic is, well, quiet right now. This upper level low is killing any chance of development around the Caribbean, and the intertropical convergence zone isn't exactly active. We have run very interesting disturbance out here, but really nothing immediate is developing, no low-level circulation, and this is a lot of dry air that basically inhibits any type of tropical development. So nothing around the Cape Verdes, nothing in the Atlantic, and our sea surface temperatures over the Atlantic continue to clearly support a negative AMO signature. So this certainly would not support rapid intensification, that is for sure. It doesn't inhibit the potential for tropical development. It's just that you wouldn't see any type of rapid formation. If anything, your best potential for that would be in the Gulf, but unfortunately you have an upper level low moving in the direction. So right now, your signal that you want to look for is an MJO in 7, 8, and 1. And basically right now we're going from a weak phase 4-5 into basically a neutral state. And that's showing up on pretty much now almost all the guidance, one way or another. Canadian, Europeans, even the JMA. So you kind of get the idea here. Now, there is potential, maybe, that we can get the MJO towards the end of the month, clipping 7, 8, and 1, but it's pretty low. So it's interesting to see that the MJO factor right now is basically neutral, and that the only thing that's really going to drive this tropical weather pattern to be more active will be La Nina itself. So the environment is favorable, but right now we're not seeing any triggers. So there's nothing really that stands out that says, wow, we're going to see a lot of activity really blossom. But let me pull this up real fast. This right here. Pull up this signal right here that I'm seeing in a lot of the guidance. When we do get tropical activity involved here, this type of signal is bad trouble for the East Coast. Let me see if I can zoom in here. And I'll pull up maybe tropical Atlantic. Here we are. Okay. What this signal would suggest is that you have a lot of weak winds here, lower heights here, so the potential for some tropical development out here will increase. But anything that develops is going to have a chance to come right up the coast because of this activity right here. So there's certainly some potential out there. So we're definitely going to keep an eye on it. But tonight, I really don't have anything that stands out like a big smoking gun that says, "Oh wow, this is breaking news and things are going to change and heavy rainfall event is going to take shape and everything's going to change in that factor." I just don't have any data to suggest that. What I do have is a lot of signals that can point to the direction of potential for heavy rainfall, but a lot of inhibiting factors. So now that I've gone through all that, I'm going to I'm going to go through your questions. I already see stuff about Sahara dust, so let me see if I can pull that up real fast. Let's see here. We'll get to that, but I want to pull up the data at least. Okay. So let's go through the questions, and I'll jump on YouTube and answer the best questions there. How brown is my grass? Everyone's grass is brown, unfortunately. Let's see. James says, I have my doubts about widespread rainfall unless we get a tropical system. That is definitely a fair assumption, a fair thought on that, on the weather pattern overall. You need either one or two. You need a synoptic scale extratropical low pressure system, which is possible, developing along this frontal boundary. You don't even need a strong low. You just need an organized low pressure system to utilize all the moisture in the atmosphere. Basically, right now, the best way I can describe it, and let me pull up. This is still a lot of moisture in the atmosphere. All you need is a trigger. Once you get a trigger, an organized trigger to utilize all this moisture, you can end up with a very impressive heavy rainfall event. It's just that it's summer and it's hard to get those type of triggers. (7:43). I just had a pop-up moderate storm here in Illinois, Pennsylvania, South Central PA. Fairly steady for 20 minutes. Sun and moderate storm gives us lasting rainbow. Oh, that's pretty cool. We're right around out here. And it is a nice line, but look at everything. Look, once it runs into this dry layer, look what happens. These thunderstorms just collapse. It's pretty impressive, really. Looking at Earth New School, there is a low from the surface up to 250 millibars, with the 250 millibar low rather strong right up to the top of the Arctic. There is light counterclockwise rotation in the same area at 70 millibars. Yeah, this time of year, though, the influence of those winds is almost negligible for our weather pattern. It's slightly enhanced a little bit because of La Nina, but the circulation is so weak, it doesn't have a significant impact on our weather pattern. It's interesting to look at, it's interesting to study, but in terms of our weather pattern, really doesn't have much of an impact. While we have had hot days, we have not so far had anything that is out of the ordinary. Very true, either in temperature itself or the number of days that are hot and humid. That is a great point. We really haven't had any heat waves, knock on wood. I think if we see heat waves, and I think we will at least see one or two. I mean, it is summer. It's going to be the variety of 3 days of 90, 91, back to 90. Okay, bless you. Where we don't really see that excessive heat wave event where like it's 97 degrees with a heat index around 110 and heat advisories are being sent out. I don't see a lot of support for that. What I do see is a weather pattern where it's just muggy, humid, and it feels like you're just walking through a wall of water, and not in a good way. Where you're constantly stuck in a sauna, where it's 89 degrees, but it feels like 94 because it's so humid out. That is the type of weather pattern that I think that we've been in and that we will continue to be in, likely into at least early August. What does the Western Pacific look like as far as tropical activity? Well, I know that, let me see, let's pull up storm activity, current storms. We have Darby that is starting to push towards Hawaii, but ready to weaken. That was an impressive storm. But that's about it. It's pretty quiet out there. Tropics are really quiet this year, which is surprising so far. Um, in terms of ace scores, it has not been impressive. Which, I mean, if you told me that heading into July we'd have below normal ace scores in the Pacific and the Atlantic, I'd be very, very surprised by that. But here we are. So as always, the weather is always going to keep you on your toes and throw you some curves. So, has the Sahara dust lessened? There's our question. I knew I saw that popping up. It has weakened a little bit, but nothing that's significant. We still see plenty of Sahara dust limiting the development, and then there's our upper level low transporting some of that dust through the Caribbean. And let's check out YouTube. All right. Let's see here. Let's see. All right. Steve, I have accepted it's never going to rain again. Can they study how we have great parameters but never get a drop of rain in these days? What's your take? Okay. Great point about the parameters. This is the thing about convective weather, and this you could also take this in part in winter storm events. When it comes to mesoscale factors, okay, you have pretty much everything in place, locked in, to go. All you need is one factor to just basically throw everything off. In this case right now, that one factor is that dry 10-meter layer of air. That's what's killing you. Now you could take this and you can apply it to winter storms. How is it that my town is getting 5 inches of snow, but locations just to my northwest or even just to my south only have a foot? Because the way that mesoscale banding works out, whether that is a moisture gradient, a thermal gradient, convergent low-level winds, all those factors, it leads to enhancing and limiting factors that can influence how precipitation output unfolds. And if you end up in a loop in the mesoscale, in the small scale, okay, where it keeps on repeating itself within the larger synoptic scale, you can get locked into where you don't see the precipitation you are forecasted for, but all you need is one factor to break that loop, and then you end up with that precipitation event. And what we're basically dealing with here is chaos theory. It's trying to figure out how that one drop, when it hits the ball, is going to move left, right, north, south. How is it going to move? And that's what we're dealing with here. So part of it as my job is, one, to understand our limitations and understand the factors that inhibit development and can enhance development, and what could override the current loop that we're in. So I know what will override this event, which would be a widespread rainfall event, but until we get that, what we have in place right now is driven by mesoscale factors. And so what you need is a mesoscale factor to overcome this loop outside of the synoptic influence, large-scale influence. So your best bet would be something like a sea breeze front. Here in Cape May, dodged a bullet. Is it possible that South New Jersey could reach 90 degrees anytime soon? Depends where you are in South New Jersey. If you're right along the coast, you have that sea breeze influence, so you might touch 90 and then get knocked back down to the lower 80s. I think it's a little bit harder right around Cape May because you're in the peninsula, so you have a kind of a three influences limiting temperatures. But I think if you're in southwestern New Jersey, absolutely. So this pattern is a Bermuda High pattern. It's a subset of one, yes. Will we be having storms with more intense winds? Storms just in Sussex County, Delaware, had winds up to 100 miles per hour. Were these caused by conditions further up the coast? Okay, this is a great question. Okay, so I'm going to use a prop. Here's my prop. Okay. This represents the moisture in the atmosphere. So what's happening here is that we have our thunderstorms that are picking up a lot of moisture. And that moisture in the atmosphere gets higher and higher until it cools and then it condenses. And then what happens? You hear that? You know what that was? That wasn't my speakers. It's fine. What that was air rapidly slamming to the ground. That is your 100 mile per hour winds. Okay? That's why you're seeing what you're seeing. It's not an influence of anything outside of those thunderstorms, but this is slamming to the ground so fast that it causes an explosion of air that reaches out from the thunderstorm. This causes what we call an outflow boundary, which expands out. Now, here's what's interesting about these outflow boundaries. At the storm itself, it can produce those 60, 80, 100 mile per hour winds, right? And it can also cause turning in the atmosphere, which can produce small tornadoes. It also can set up boundary layers that ignite other thunderstorms. This is a factor we're going to have to watch out for as we get more and more of these storms. But as long as you have this deep moisture crashing to the surface, that's how you get those strong winds. Sorry, hon. All right. Why haven't we experienced widespread severe weather outbreaks? I don't know. I think we've had, to be honest with you. I kind of disagree with that question. It may not impact your location, but we've definitely had region-wide severe weather outbreaks. In terms of like a derecho or something like that, where it literally hits everybody, those events are really rare around here. You have to understand, we're in the mid-Atlantic, and we have a lot of inhibiting factors. So that's hard to pull off. Okay. Newark Airport got to 96 today. 94. Okay. Sorry, first I was right 90s. That's me. I should know that. Yeah. Here's the thing. Newark Airport. This is going to be very interesting to watch out. Newark Airport. Let me pull up this. And let's zoom in. Okay. I'm going to be keeping an eye on this area right here. See this area right here that I'm circling? This is our I-95 core, Delaware River Valley heat zone. You have a combination of air downsloping off the Appalachians and the Hudson Highlands, and you have your urban heat island effect. All in this factor right here. Why am I going to be keeping an eye on that? Well, if you have temperatures bumping up to 96, 97 degrees, and then you have your sea breeze effect, where you have your temperatures in the lower to mid 80s, that's going to develop a pretty nice thermal gradient right from, let's say, Queens, Nassau, Queens, JFK, Staten Island, Middlesex, Monmouth County, Burlington, and Ocean counties. Right in here. I am watching out for the potential for thunderstorms being ignited by that sea breeze front, enhanced by the urban heat island effect. The urban heat island effect leads to rapidly rising air. Combine that with plenty of moisture, you get your thermal gradient, you get your cumulus development, boom, slow-moving thunderstorms hanging right around the I-95 corridor. It's not a slam dunk, but it's a theory. I think we're going to see that a little bit more over the next 2 weeks. So I'm going to be keeping an eye on that. Model guidance has been kind of hinting at that. So it's something that I'm definitely going to be looking out for. It's a perfect example of human-influenced mesoscale climate enhancement, where your urban heat island effect, which is your concrete, your roadways, your airplanes, electrical output, your air conditioning use, all that stuff, puts out additional heat and enhances the natural thermal gradient that's already in place, which could lead to enhanced thunderstorms. Enhanced thunderstorms that don't move very much, with plenty of moisture. That's how you get your 3-inch rainfall event. Remember a couple of summers ago, it literally flooded out parts of the parkway because you had a thunderstorm just sit right around Newark and drop 4 inches of rain because the thunderstorm just wasn't moving, and you had plenty of moisture to tap into. Could you forecast that? You couldn't forecast that out 4 hours ahead. You had to see how the line developed, and then you saw that evolution take place. So, let's see. We have more questions here. So far, some great questions tonight, guys. Absolutely outstanding. Let's see if we have anything YouTube. All right. So we already discussed what would break this dry weather pattern. Really, it's not. I want to be careful here. It's producing dry results, but I wouldn't call this a dry weather pattern in terms of the potential. The problem is that we're stuck in a mesoscale loop, but the synoptic pattern itself, on average, would produce near to above normal rainfall. The problem is that it's all driven by convective rainfall. In convective rainfall, you have a lot of hit and misses. So that's the issue here. Now, in order to transition to more of a widespread rainfall event, I think that you need to introduce more tropical influences. My outlook on hurricanes for this year has not changed. I still expect an above normal season. Again, we typically see most of our activity August, September, and October. So I would not let your guard down. That is for sure. So I'm still expecting an above normal season. We'll see how that works out. Let's see here. If you were just outside where the storm was, you basically got nothing except for a breeze. Yeah, that's essentially it. If you are just outside of these storms, you basically get almost nothing out of this, unfortunately. So we got about 17 minutes left, and then I'm probably going to call it a night. I'll take any of your additional questions, but I basically went over what I was looking for in terms of what I wanted to cover in this chat about this weather pattern. It's very interesting to see what we're looking at for this evening. You see these thunderstorms? Look at where this evolution is taking place. Look where all these thunderstorms are taking place. And look at our moisture gradient. Let me zoom in. All of our storms are igniting around this moisture gradient right here. And it's enhanced by these stationary fronts. And to the south of the stationary front, we're seeing more southeasterly southerly winds, southwesterly over eastern Pennsylvania. Markedly warmer, lower to mid 80s out here, upper 70s along the coast, more of an influence from the Atlantic. But notice the dew points are far different. Look at this. Upper 50s to lower 60s, a lot more moisture along the coast, lower mid 60s to lower 70s. So again, you have different boundary layers, different atmospheric factors, and plenty of moisture. And days are starting to get noticeably shorter. That is true. I I am very happy to hear that. You know me, I'm more of a fall and winter guy. I do not enjoy the heat, and you could take the 9 p.m. Sunlight. Thank you very much. I am ready for fall and winter. I think I was ready for it in June, to be honest with you. Let's see here. Quite the moving of the winds over here around these areas of America, isn't it? Insurance stuff in general. Okay, I'm not really sure what that means. Will it get hotter or cooler? On average? Well, all right. The summer right now, we're at the peak of summer. So we're pretty much, I think that we're at the time period where we should see temperatures remaining above normal through about mid-August. And then from mid-August on, you start to cool off. That doesn't mean that you can't get a heat wave in September, by the way. Weather pattern evolution is never uniform, okay? You get ups and downs. So the weather pattern typically goes like this. It goes up, down, up, down, up, down, up, down, okay? So, and in the spring, it goes up, 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 right? So overall, I'm expecting still above normal temperatures for the rest of the summer. And I think we'll see that. I think we'll see near to above normal precipitation along the coast. I think that the interior still is a bit more of a question. But that's been my thoughts overall. My thoughts on the summer and the tropics really haven't changed all that much. And it's pretty much been aligned with what I've been expecting. Excuse me. NFL training camps open up soon. That's true. I'm looking forward to the Chiefs this year. I think they're going to be much better. They were great last year, don't get me wrong. I just think that the offense is going to be more diverse. And a certain somebody in Miami is going to be talking a whole lot. It might be eating some of its words. So we'll see how that works out. Meanwhile, I got my Mets are doing pretty good. Let's see here. Okay. We already answered most of these questions, so we're good there. Yeah, I already answered it. Yeah. Let's see. I think that that's pretty much it for tonight. I think we answered all the questions we had to answer. We did our coverage. So I will see you next week. Maybe we'll have a little bit more to talk about. Maybe we'll have a tropical system. Who knows? But I think we pretty much covered everything that we wanted to cover for tonight. I hope you enjoyed the chat, and I will see you here next week at this time. Have a wonderful night and a wonderful week, and as always, stay safe out there.